We like to think planets are sturdy. Big rocks, thick atmospheres, oceans, mountains, a whole world that feels permanent. But in the universe, permanent is a comedy genre. A planet can look stable for millions of years, and then one event, one slow process, or one unlucky orbit can turn it into a dead sphere. Not because the universe is evil, it's worse than that. It's careless. Tonight we're counting down 5 ways the universe can kill a planet. Some are sudden, some take ages. But all of them prove the same thing. A habitable world is not the default. It's a miracle with a timer. Let's start with number 5. Number 5. Atmosphere stripping. When a star peels a planet bare. Imagine living on a planet that's slowly being erased. Not destroyed in an explosion. Not smashed by an asteroid. Just gradually losing its air, molecule by molecule, until the surface is exposed to space like an open wound. This is atmosphere stripping, and stars do it all the time. Young stars are especially violent. They blast out charged particles, intense ultraviolet radiation, and strong stellar winds. If a planet is too close, or if it lacks a strong magnetic field, that wind can literally blow the atmosphere away. It's like holding a lit candle in front of a giant industrial fan. Eventually, the flame doesn't fight back, it just disappears. Over time, the planet goes from breathable air to thin air, from thin air to trace gases, and from trace gases to basically nothing. And without an atmosphere, you lose everything that makes a world feel alive. No stable temperatures, no liquid water on the surface, no protection from radiation, no weather that cycles nutrients and energy. Mars is the classic example we look at and quietly try not to think about too hard. Because Mars is basically a reminder that a planet can be almost right and still end up as a frozen desert with a sky too thin to matter. Atmosphere stripping is terrifying because it's invisible in a daily sense. You wouldn't notice it on Tuesday. But over geological time, it's planetary suffocation. Number 4. Runaway Greenhouse. When a planet crosses a line, it can't uncross. Now let's talk about a death that's slower but far more brutal. A runaway greenhouse happens when a planet's climate crosses a line it can't uncross. Here's the nightmare loop. The planet warms up. More water evaporates into the atmosphere. Water vapor is a greenhouse gas, so it traps more heat. More heat evaporates more water. Repeat until oceans become steam, and the surface turns into an oven. At a certain point, the planet stops being a bit hotter. It becomes fundamentally different. The oceans don't just shrink, they vanish from the surface. Cloud systems change. Chemistry changes. And the atmosphere turns thick and crushing. Venus is the poster child for this kind of apocalypse. It's roughly Earth-sized. It's made of familiar materials. But its surface is hot enough to melt lead, and its air pressure is crushing. Venus is terrifying because it looks like it could have been Earth's twin. Instead, it became a warning label floating in space. And Runaway Greenhouse isn't just about heat, it's about losing control. Once the feedback loop takes over, the planet doesn't stabilize. It accelerates into disaster. A planet can go from potentially habitable to completely sterilized without a single dramatic explosion. Just physics doing its thing. Number 3. Impacts. Space debris turns the sky into a weapon. Now for something more immediate. Impacts. Asteroids and comets are the universe's way of saying, your planet looks nice, shame if something happened to it. A major impact can kill a planet in multiple layers. First, the explosion and shockwave. Then, heat, a lot of heat. Then, ejecta, thrown into the atmosphere, blocking sunlight. Then, global climate collapse. In extreme cases, you get worldwide firestorms, acid rain, years of darkness, collapsing food chains, mass extinction. It's not subtle. The scary thing is that a planet doesn't need to be hit by something gigantic to suffer. Even a smaller impact, if it hits the wrong spot or triggers the wrong chain reaction, can cause climate shifts that last centuries. And there's a deeper horror here. Impacts don't care if a planet is thriving. They don't care if evolution just produced something brilliant. They don't care if you built cities, wrote music, or finally invented decent coffee. Space is full of debris, and gravity makes sure that sometimes trajectories intersect. A planet can be thriving on Monday and mourning on Tuesday. Number 2. Tidal destruction. when gravity tears a world apart. This one is less famous, but it's the kind of cosmic violence that feels personal. Gravity doesn't just hold things together. If the forces are uneven enough, gravity can rip you apart. This is tidal stress. If a planet or moon orbits too close to a massive body, like a giant planet or a star, the gravitational pull on the near side is stronger than on the far side. That difference stretches the world like it's being pulled in two directions at once. Sometimes, that stretching just causes heating and volcanism. Sometimes it causes cracks, quakes, and surface reshaping. But if the orbit gets too close, the planet can cross a point of no return. The tidal forces overwhelm its internal strength. And then the world doesn't break. It disassembles. Pieces can form rings. Debris can spread into a disk. A planet can turn into a field of fragments, all because gravity decided to be creative. Even without total destruction, tidal forces can make a planet unlivable. Constant earthquakes, extreme volcanism, a surface that never stabilizes, an atmosphere poisoned by continuous outgassing. A world can become a chaotic furnace of geological violence. The terrifying part: this is not rare in principle. It's a normal outcome of orbital dynamics. If you live in the wrong gravitational neighborhood, your planet isn't a home. It's material. Number 1. Gamma ray bursts. The cosmic reset button. At number 1, the most terrifying kind of planetary death, because it can come from absurd distance and still matter. A gamma ray burst, or GRB, is one of the most energetic explosions we observe in the universe. It happens when a massive star collapses or when extreme objects merge, firing a narrow jet of high-energy radiation across space. This is not like sunlight. This is a beam of photons violent enough to shatter molecules and hammer atmospheres. If a sufficiently close GRB were pointed directly at a planet like Earth, it wouldn't need to hit the ground. It could damage the ozone layer, increase harmful radiation reaching the surface, disrupt climate chemistry, trigger ecological collapse, and the planet might still look intact from space. No crater, no broken continents, just a world that quietly becomes hostile to complex life. What makes GRBs so terrifying is the geometry. They're narrow beams, so most of the time you're fine. But if the universe lines up the shot, then it's not a natural disaster. It's a global atmospheric catastrophe delivered at the speed of light. You don't defend against it. You don't evacuate. You don't even get a warning, because by the time you detect it, it already happened. So those are 5 ways the universe can kill a planet: atmosphere stripping, runaway greenhouse, impact events, tidal destruction, and gamma ray bursts. And here's the uncomfortable truth behind all of them. A habitable planet is not guaranteed. It's a balancing act. A lucky orbit, a protective atmosphere, a stable star, and a long stretch of good timing. Earth isn't safe. Earth is currently surviving. And in a universe like this, that's already impressive. Thanks for watching. If you enjoyed this, hit like and subscribe for more space science and real cosmic horror. Now it's your turn. Which one was the scariest? Comment below.